In the economy and world today, the efficient use of resources should be a goal for all agricultural producers. With virtually no plots of land being converted into agricultural production, it is important to take care of the land that is available. Overproduction and excess use of chemicals and fertilizers can lead to detrimental effects on farmland. Satori found that one of the major factors that determine a crop's ability to capture resources is the plant's density. This means if seeds are not planted correctly to account for growth, water availability, and resource availability, the crop will not produce to its maximum capability. Using chemicals and fertilizers improperly has led to water contamination and water resource shortages. The objective of the study is to compare radish outputs using different seed densities and nitrogen application levels. It is hypothesized that the radish plants that are planted in a group of 50 seeds with 0.5 grams of nitrogen will be the highest yielding plants, and that there will be significant differences between the seed densities and nitrogen levels.
Do you want us to fill it too while you're doing this?
In this laboratory exercise, we will examine the effect of increasing plant density on total yield and determine the yield curve and optimum plant density for 4 seeding densities. We will do this with 4 different nitrogen fertilizer regimes. We will begin by filling 16 planting pots with an equal amount of sand vermiculite, and then place each of the 4 planting pots in 4 trays. We will then be applying 1 gram of 0-10-10 fertilizer to each of the 16 pots. This fertilizer does not contain any nitrogen, but does contain 10% phosphorus and 10% potassium. We will then be counting out 25, 50, 100, and 200 seeds to put in each of the 4 pots for each of the 4 different amounts of nitrogen that has been added.
Right every once in a while. You haven't had
Here we are measuring out ammonium nitrate for each tray. This is the 0.25 grams. For each tray, we are measuring out the different
We will be labeling each label with the amount of nitrogen added as well as the seed density that will be put in each pot. We will then be planting each seed after we have thoroughly mixed in the amount of fertilizer that is going to go in each of the set of pots. Here we are mixing in the amount of nitrogen for these pots, which is 1 gram per pot before we plant. Over there they are currently planting the seeds for each pot to the correct amount and the right density. Here are ending products of the radish being grown, shown in the order from no nitrogen to most nitrogen. We're now going to cut off the top foliage of each one and weigh it to determine the amount of fresh foliage, I guess. Here we are getting ready to cut the foliage off of the first pot to measure for fresh weight. And this is us beginning in the 0 nitrogen pots. Here we are weighing each amount of foliage to find out what the weight is for each seed amount at each nitrogen amount. And here we are recording the data, so we have a record of what our weights were.
From the analysis of variance that was run, figure 1, the p-value of each observation is less than 0.05. This means there is significant difference between the nitrogen, seed densities, and growth. With the significant differences provided, proof that using different rates of nitrogen affect the growth and efficiency of radishes. As seen in Figure 2, the plants that were in the plot with 200 seeds and 1 gram of nitrogen had the greatest root growth. Another observation that can be made is that plants need nitrogen in the fertilizer that they receive. All the plants with no fertilizer were significantly smaller than the rest, and there were some discoloration of the leaves and shoots. Although this experiment showed more nitrogen meant more growth, there has to be a balance between the plant needs and the application rate. The Turkey analysis was run to compare the different groups to determine if there was any that were homogeneous. In Figure 3, it is determined that there are no homogeneous groups when nitrogen levels break down the groups. In Figure 4, it is determined that there are no homogeneous groups between the seed densities either. Both Figure 3 and 4 are more proof that there is significant differences in growth between the seed densities and the nitrogen levels that are applied. Through the testing and observation of 16 different experimental units, it has been proven that there are significant differences between the nitrogen levels and seed densities. The highest yielding plants were the ones that had 1 gram of nitrogen and 200 seeds planted in the individual plot. These results show that the use of nitrogen is needed for the production of agricultural crops, but should be used efficiently. The major factors that will affect and possibly detriment the growth of plants are overpopulation and lack of nutrients. All agriculturists and gardeners should be aware of both of these things. If plant producers were more aware of the nutrient needs and application rates, nitrogen runoff, contamination, and water resources for the future, it could be in better shape.